Hello everyone, Reza here. Welcome to my channel. In this tutorial, we'll explore machine learning in Nuke, focusing on the CopyCat plugin. Introduced back in 2021 and improved with each release, this tool helps artists train neural networks to create custom effects for image-based tasks. We have a lot to cover, so let's get started. Here I am inside Foundry Nuke. Let's look at the footage. A guy is looking into the camera. What I'm planning on doing is human matting. So basically I would like to remove the background and replace it with this background. I've already reformatted, I've already matched the whites and blacks, and I've got a merge node B-pipe set to the background, ready to go. Well, on a normal circumstances, you need to go and roto this guy, frame by frame possibly. If there is not much movement, you can kind of repurpose the previous roto and animate and move the points to be able to get it done. With the new CopyCat plugin, we are going to get rid of this laborious task, and we'll let the machine learning to take over and get the bulk of the work for us. Now, where should we start? We always examine the footage. We need to think about the movement of the footage, and we need to create what Foundry calls frame selection. So frame selection is crucial to CopyCat, and in this first chapter of this tutorial, we'll explore how to choose frames effectively for both input and the CopyCat channel, which we call ground truth images, and have a better understanding of the process. To create our frame selection, we use frame hold node in Nuke. The question is, where should we put those frame hold nodes? Every time you have variations in the shot. So you can see right at the beginning, this can probably get covered by a frame hold. If I scrub through, the guy tilts his head. Now that's the bit that we have a little bit of variation, motion variation, and that requires a different frame selection. Right at the end, the guy tilts his back again, and that requires a separate frame selection, or frame hold in that case. I'm going to type frame hold, and for now I'm going to create 3 frame holds, and that is going to be my frame selection. According to Foundry, around 2 to 30 images consider small dataset collection that we can use as our frame selection. So the minimum number that you can have is kind of around 2, and you can go all the way to 30 frame hold nodes to cover for more interactive, dynamic, and complex images. For large data set, I mean long shots where you have a very fast moving object, you may go up to 1,000 frame holds. So let's actually think about what do I mean by saying variations. Now, we did look at one instance when we had motion variation. So a noticeable movement in the main subject is going to cause for one of these guys to be created. If you have change in lighting, you also need to think about that, and that can be counted as a variation. If the focus of the camera changes, including both in focus or out of focus frames within your footage, that also requires a frame hold. What I'm going to do, I'm going to create a dot node, pressing dot on the keyboard to create a dot node, and I'm going to connect these guys to my dot node. Now, at the moment, if I double click on it, I'm going to reduce my number of panes to 2. If I double click on it, it's just looking at the frame that I created these frame holds. But to tell you the truth, we looked at the first frame, we looked at the one right in the middle, and we looked at the one right at the end. So let's go ahead and put the correct numbers in there. The first one is going to be frame 1. So I'm just going to go to frame 1. Alternatively, you can go to frame 1 and set to current frame. The second one is around frame, let's say 70. So you can see that's where we have motion variation. So let's go and set that one, set to current frame, or type in frame 70. And I'm going to switch from global to input so I can see the entire range. Yeah, and that also requires another reference frame. So around maybe 169. So I'm going to double click on the third one and create a reference frame. So the first one is frame 1. The second frame hold is on frame 70. The third one is on frame 169. Also, keep that in mind. If the background behind the character or behind the main subject changes frequently, such as when the character is running and you can see buildings are passing by behind the character, you need to also include reference frames for those moments. So keep that in mind. That's part of the motion variations that I was talking about. Also, another tip about frame selection or creating your reference frames: if you are changing a small section, let's say a bruise on the neck, you can augment the data by creating a reference frame and cropping that section or transforming your roto so the background and foreground look slightly different. This approach maximizes the learning of the CopyCat engine. Now we have a better understanding of frame selection, which is pretty much the first step of the way. Let's go to the next chapter and talk about how we can provide roto for each one of these frame holds. Well, before I do that, I need to do one thing on this node tree right before frame hold, and that is to drop in a frame range and set that frame range to 1. At the end of the day, when we put roto underneath these frame holds, we would like to append clip them. So we only deal with 3 frames instead of 176 frames. And to do that, we need to have a frame range in place right at the beginning. So this frame range goes from 1 to 1. So we literally looking at 1, 2, 3 frames when we drop in append clip node. All right, let's get to roto. The shortcut for the roto node is a letter O on the keyboard. So if I type in letter O, we have the roto node for this guy, and then we need to create 2 extra roto nodes for the 2 frame holds or our frame selection that we have. If you have 10, then you require 10 roto nodes. I'm going to double click on it. We need to make sure that this one is set to spline. I probably give myself more real estate. I can zoom in with my scroll, hold, or push down. You can sort of move around, and at any point of time, if you create something and you realize that it's a mistake, just press Ctrl Z and you can continue. Because we're using Bezier, when you click, if you drag, you can get the handles, right? That's another tip. If you don't want to have jagged edges, let's say I finish this hypothetically, you can actually go into select this guy and tap Z. That is going to make this one smooth. If you want to cusp it, you select your point and you press Shift Z, and that is going to cusp it. So Shift Z is going to cusp it, and Z is going to smooth the curve. Right, now we know how this works. Let's go ahead. I'm going to delete that. Let's go ahead and create our roto on the first pose. In order not to make any mistake, I always select the frame hold. I press 1 on it, so I make sure that I'm on the first frame. Then I'm going to select the roto node and press 1 on it, so I know that I'm on the same reference frame that I'm painting the roto. Same goes with the second one, same goes with the third one. So I'm just going to go press 1 on the frame hold, select the roto node, press 1, and getting to work. Now this is going to take a little bit of time. One last tip, be picky about the way that you do roto. Try to be as accurate as possible. Remember, you're rotoing only 3 frames and not 179 or 76 frames, so you might as well be as clear as possible. Another thing is when you are actually rotoing the entire character, I know a typical practice in rotoscopy in Nuke is you get multiple splines, but according to Foundry, CopyCat actually likes one single roto on the character. All right, I'm going to either speed up video or I'm going to cut to where I'm finished, and we are going to get back and continue with our tutorial. All right. I spent only a few minutes and went through rotoing the shape, the main subject. I tried to be as accurate as possible, and again, a single roto is preferred. Doesn't mean that you cannot get the ideal result with multiple simple splines, but just one Bezier will suffice for CopyCat to do its training. Another thing is in each roto node, I did enable replace. So as you can see, it clears the channel to black. And if I now press A on the viewport, you can see I'm getting a clean result. I did the same thing for the second one and same thing for the third one with replace on. Now it's time to select all 3 and connect it to the append clip node, a node that we don't use too often. So I'm going to bring append clip. The order is quite important. So the first one gets the first input, the second one goes into the second input, and the third one goes to the third input. If you mix them around, you get a weird result. Now the idea is to now connect this to our beloved CopyCat. And again, the CopyCat node has got 2 inputs. One is where it's going to train the model, and the other one is the footage. Well, the footage goes to append clip, is the footage, and the ground truth is going to look at the result that we select as our matte. So to do that, we need to make sure the first input doesn't include matte, because we are going to work out or train the matte using the ground truth. So what I'm going to do, I'm just going to bring in a remove channel, and I'm going to say to remove channel to keep only RGB, not RGBA, because RGBA goes that way. Now with this, let's do the opposite. Let's create a shuffle node, and in here I'm going to connect RGBA alpha to these guys. That goes into my append clip. Now, in this case, I'm going to only work with the red channel. So I'm going to go remove, just like the other one. But in here, I'm only going to keep the red channel. So I'm going to bring RGB and get rid of these guys. You can even bring RGBA, get rid of these guys. And that goes to ground truth. I'm holding down Control to create a dot that is nice and clear. So to repeat, this stream does not have any alpha, and this stream has got alpha, but in just one channel. So we can easily transfer it into our alpha channel of the footage later on using a simple copy node. So if I go in here and press 1, you can see this is just red, but it's representing the alpha that we created. And if I go in here in the other remove, this does not have any alpha. One goes to the input, the one without alpha, and the alpha goes into ground truth, and that is specifically made for CopyCat to train the mat and create human matting. I can even go in here, change the color of this node to something very noticeable, like red. Perhaps I can use this one so it's more noticeable, and take it from there. Now, the important stuff. In the CopyCat, we have few sets of information that we can benefit from. The first one is using GPU if available. And if you have a good GPU, I highly encourage you to do that to speed up the process. So I have GeForce RTX 4090, and you can see the system is detecting it and benefits from it. The other one is where to save the .cat files, because later on when we train the model using the CopyCat, we need to create Inference node, and that Inference node is going to read through the cat files that we're creating here, which is more of a contact sheet that CopyCat creates in order to generate or view the mat. Then we have epochs. Let's start with what epochs is. Epochs is, well, represents the number of times the model trains on the entire dataset. For small datasets, something like this, where there is no complexity, around 15,000 all the way to 50,000 will suffice. But if your computer allows you to go higher for better training, do that. Just remember that increasing epochs will significantly take longer as you increase this value. For lengthy, complex shots, you're allowed to cancel the training halfway through and examine the process within this chart right here, which I will talk about very shortly. And if you feel like the training is going smoothly, you do not need to finish the training. You halfway through, you can stop that and create your inference node. So for this particular example, I will start with 50K. I noticed that something around 40 to 60 gives me a really good result. However, if you put that to 50 or 60, you need to make sure that you have a decent graphics card to be able to handle that. It's not about calculating, it's about the time that you need to wait for the CopyCat to finish training. Now, usually artists just start training in here right away, but I just want to touch upon the advanced rollout, because if you know how to work with this rollout, that can significantly speed up your workflow. The most important one is pre-weight training, initial weight, which Foundry calls pre-weights training. And that is few presets that you have available based on what you want to do. If what you want to do is get rid of defocus or deblur, then you can select that. For upscaling your image, you can select that. And in my case, I'm doing human matting, small, medium, and large, and that refers to my data set. Human matting medium should do just fine. And as soon as I do that, you can see model size changes. If I set that to 1, you can choose how complex your data set is. The general advice is if you're doing upscaling or deblurring, you potentially can get away with small model size, which can speed up your training length or duration. But for human matting and complex shots, usually go with medium. For long, complex shots, you go with large. And just like epochs, if you increase that from small to medium and medium to large, you have to wait longer for the training to be finalized. So the benefit of using pre-weights training is it significantly speeds up the training process. There is a fourth one in here, which is checkpoint. and it's a bit more advanced. I'm not going to talk about it perhaps in this tutorial. We may put together a separate tutorial just to talk about that. But just so you know, it allows you to create your own custom pre-trained model. For example, you train the model on one shot and then use it on a separate but similar shot. With that, you can actually use checkpoint. We may get to that in future lessons, but at least for this one, we have a very specific purpose in mind, and that is to get the copycat to create a matte out of this so we can replace the background. So human matting medium. All right, let's close this rollout and start our train. I'm going to speed up the video just so you know from my end on my computer, it's going to take roughly around 6 to 7 minutes. Before I do that, I need to specify the path. Almost forgot. So I'm going to go in here. I'm going to create a new folder, cc4, and open. So I have a clear path ready to go and start training. Now, as you can see, we have a window popping up here, and this window is actually important. It says that what the input is, and the ground truth is trying to train the model and output it based on what we're having here. And if you see resemblance, great resemblance between your ground truth and your output, then it means that you're in a good place, and potentially you can even cancel your training and create your inference node. Just note that it's not a requirement to go all the way to 100 in order to get a good result. Sometimes if you stop your training prematurely, you can see pocket holes or inaccuracies, halos around your alpha. So it is suggested or recommended to keep an eye on the crop sections from different locations that CopyCat is capturing to train the model and make an executive decision based on that. Because I'm using a high number of epochs, you can see there's a great deal of resemblance, but you see the artifact that I'm getting here, and this is not something that I have in my ground truth, and that should give you enough clue to say, all right, I probably need to let that calculate. It's still not quite there yet. As we move towards 100, you can see these two become more and more similar. Another way to check whether you're on the right path or not, while it's calculating, you can actually go into progress and check your loss curve. It actually starts from a high value and it should diminish and go down. If that is the case, then it's another indication that you're towards the right path and your training of a model is in a good path. Now I'll wait and let this to be fully finalized and see you all in the next chapter. All right, I let the whole training to go through all the way to 100%. I believe that's almost going to guarantee that you are going to get a good result. Now this is done, it's time to create inference node. If I create an inference node, this holds the model files, and that allows you to automatically control the references that you get out of CopyCat and use it as your mat. I'm going to move that up. That needs to be connected to your main footage or to the input. If I double click on this, you can see the path is there, and if I go to node, I can enable postage stamp. And if I look into it, I have the interpolation between these 3 frame hold nodes that I created. So remember, we only created 3 rotos. Now look at that. We're actually getting the entire image out of those three. And that is the power of machine learning. It's incredible how this saves time on what you have instead of having a tedious task of rotoing every single frame. That gets the job done for you. And again, almost a similar framework can be applied to any beauty work that you want to do on your model. If you want to paint out certain areas, if you want to de-blur, or if you want to upscale, please do let me know in the comments below if you are interested to see more of these copycat videos. And I'll promise I'm going to set some time aside to show you more examples. It's just so incredible how time-saving this copycat node is. We have this red matte. Let's inject that into an alpha so we can use copy to bring that into this very image. So that's really easy. I'm going to drop in a shuffle node and plug that in. And in the shuffle node, I say, well, the red goes to red. That's okay. But red also goes to alpha. And that hopefully allows you to have an alpha now. Because this guy didn't have an alpha. Now we have the same picture, but in alpha we have the same thing. And this is the one that we use in order to extract the background and replace it with, let's say, this one right here. Now, if I look at the gamma down, you can see there's a bit of a pocket hole going on here, which can be easily fixed using a grade node. So I'm going to drop in a grade node, and I'm only targeting alpha. I'm not really interested in the red color here because we're not going to use that red color. We're going to use the alpha. And if I zoom in, I can simply play around with white points, lower it to get rid of the black areas, and ever so slightly increase the black points to get rid of any artifacts that I may have around this object. So you can see if I lower the white point, I'm immediately getting a fantastic result. Maybe 0.9 would be a good value, and my gamma is almost all the way down, which is pretty extreme. And perhaps increasing a black point to something like 0.05 just in case, and we're good to go. Now, it is super important to check your values. If I go in here, you can see we have now super whites, and super whites can create issues. Always clamp your values. You should not have any negative, and you should not have any super white values. So with the grade, I'm going to immediately clamp it. So if I'm going here, you can see there is no value over 1, whereas in here, you can see the alpha value or the red channel get more than 1 in pixel values. If you would like to keep the super white values, you have no choice but to train in logarithmic color space. And that has got its own flaws. It will result in compressing the color values, and I do not recommend that. So general advice, always bring the clamp in here and make sure there is no value over 1. Now it's time to use a copy node and plug that into our reference using the matte that we got from CopyCat. So I'm just going to create a copy node, or you can press K on your keyboard to create CopyCat. Remember, don't use C. C is reserved for color correct. So A goes into clamp, B for base goes in here. And of course, right after that, I'm going to switch back the gamma. Right after that, we can pre-mult it. So we get rid of the background altogether using the matte. And there we have our clean result. Now this pre-mult can go into my merge node. And with that, we have the final result. This is pretty much the gist of how CopyCat works. I try to stay away from complex scenarios just for you to understand what's going on. Again, let me know if you are interested to see more I'm just going to load up another example of mine, which I did a while ago. And that is using a green screen. And yes, you can key the green screen, and this one admittedly is a single click keying, but if you get an uneven result for your green screen or blue screen, if it's just too dark, the lighting is terrible or uneven, you can pretty much use the same thing. So you can see copycat happens here using a copycat node, and this we went through that step by step. And then in here I created an inference node and despilled the image to get rid of the color pollution that you get against green or blue screen. And in here I keyed only the facial hair, copied that alpha into a copy node, pre-mold, and injected that into the merge. And after this you can comfortably put a write node and write that as well. I'm using the same, funny thing is I'm using the same background for this one as well. So that's all there is to it. To be honest with you, there is really not much else to discuss. I hope you found this video useful and use CopyCat in your project, whether you're doing beauty work, deblur, or human matting. Thank you very much. As usual, you can find me on Instagram, Reddit, and X. Have a great rest of your day. Talk to you guys later.